Okay, this lecture is over Module 2 of your curriculum, which I have up on the screen. Its title is Switching Concepts. So we're going to be learning about switches and switching, which is why you should take this module to learn how to connect and configure switches and to learn about how switches operate or function. In particular, down here at the bottom, two of the main things we're going to talk about is switching domains and how frames are forwarded through switches. So the first thing we're going to talk about is that frame forwarding. They use a couple of terms here which you may or may not have had in Cisco 1. I don't recall using them, which is ingress and egress. Ingress means coming into, egress means leaving. So you talk about building egress or safety egresses if you're talking about floor plans or buildings. But in the case of switches, we're talking about ingress, frames entering the switch, egress being frames leaving the switch. So here you should have seen something like this in Cisco 1. We have a 6-port switch. The MAC addresses are shortened down so they're easy to refer to. So these are kind of made up MAC addresses. And then we actually have what looks to be a fully populated MAC address table. So what happens if we play this animation? A frame is going to come into the device and then is going to be sent out or egressed out the port that the destination device or the destination MAC address is on. Again, since this looks to be a fully populated MAC address table, it should only leave one port. Just to refresh your memory, if a packet comes in, the destination MAC address is not in the port table, then it will flood it out all the other ports. And by all the other ports that have devices attached that are not the ingress port. So I'm going to make this a little bigger and play the animation. So our port comes in port 1. The destination MAC is EA, which from our table we can see is port 4. So the packet will leave that. Here we have one coming in port 5, and the destination is EE, which is port 1. Here we have a packet coming in 3, going for AB, which is port 6, and leaving. So that's just showing you the process of switching. And again, that switching is done based upon the destination MAC address. This should be review as well. The switch has a MAC address table. That is the MAC address for the device or possibly devices that are connected to a switch port. The way you get multiple devices connected to a switch port is by typically having a hub, which is an older device that then has multiple machines. So as the switch sees packets, it'll look at the source MAC address and place that in the address table if it is already not there. And that process is called learning. It is learning where devices are in relationship to the various switch ports. Switches learn and forward packets. Again, that's a little bit of review of what I just said. The learning is learning where devices are. That is when a frame comes into the switch. It looks at the source MAC address and records that if it's not already in the table. And then the forwarding is looking at the destination MAC address and forwarding the frame out the egress port based upon, again, the destination MAC address. So here's a 3-minute, 5-second video that's going to talk about the MAC address table.
In this video, PCA is going to send an Ethernet frame to PCB, and PCB is going to send an Ethernet frame to PCA. We're going to examine how switches S1 and S2 build their MAC address tables, and also how they forward frames based on the information in those MAC address tables. PCA has an Ethernet frame to send to PCB. The source MAC address of the frame is 000A and the destination MAC address is 000B. The Ethernet frame is sent to switch S1. S1 receives the Ethernet frame, examines the source MAC address, and notices that this MAC address is not in its MAC address table, so it adds the MAC address and the incoming port number. Next, switch S1 examines the destination MAC address and notices that this MAC address is not in its table, so it floods it out all ports. PCB receives the Ethernet frame, examines the destination MAC address against its own MAC address, and notices that that is a match and receives the rest of the frame. The Ethernet frame continues to be forwarded to switch S2. Switch S2 examines the source MAC address of the frame and notices it is not in its MAC address table, so it adds the MAC address and the incoming port to its MAC address table. Next, switch S2 examines the destination MAC address, notices that is not in its MAC address table, so it floods it out all ports. PCC receives the Ethernet frame and its MAC address does not match the destination MAC address of the Ethernet frame, so it does not accept the rest of the frame. The router receives the Ethernet frame, examines the destination MAC address against its own MAC address, and notices it is not a match, so it does not receive the rest of the frame. Now let's have PCB sending a frame back to PCA. The source MAC address of the frame is 000B and the destination MAC address is 000A. PCB sends it to switch S1. S1 notices that the source MAC address is not in its MAC address table, so it adds the MAC address and the incoming port number. Next, switch S1 examines the destination MAC address and notices that MAC address is in its MAC address table, so it sends it out just port 1. PCA receives the Ethernet frame, examines the destination MAC address against its own MAC address, and notices it is a match, so it receives the rest of the frame.
Okay, that was a very good animation showing the learning and forwarding and in some cases flooding processes that switches use. So next we're going to talk about two different methods of forwarding frames. We'll talk about these in more detail in the next two sections. But there's store and forward. Basically the main thing about that is it reads the entire frame in and then checks it to make sure it's valid and then sends it out the destination ports or ports. And the next type we'll talk about is called cut-through switching. Basically, you wait until you have the destination MAC address, and then you just go ahead and start forwarding the port. So we'll talk about those in a little more detail. So as far as store and forward, like I said before, it reads the entire frame, which allows it to check the frame checksum to make sure the frame is valid. It will buffer, which means store the packet in memory, basically. And then once it knows that the frame is intact, it will then look at the destination MAC address and forward that packet on. As opposed to cut-through switching, as soon as we see the MAC address, we go ahead and look at the MAC address table and start forwarding that frame to the port or ports that it's destined for. Now, because we start at this point right after we have the frame header that has the destination MAC address, it starts forwarding. So, you know, it's not going to check the frame check sequence because it's already started forward in the frame. So that's just going to take processor time. So it's going to forward it on, and wherever that frame ends up, those devices, as long as it's not another switch doing cut through switching, will check the frame check sequence to make sure the frame is valid. Okay, here's a new type of activity. I know the version 6 curriculum had this activity in it. The version 7, the current version of Cisco 1, has it in it, but they're showing it to you again. Um, I have 2 or 3 favorite activities out of all the Cisco classes, and this is probably my all-time favorite. So basically what they do is they show you a switch and they show you a connection, and like I talked about before, here we have a hub, and they show you a frame that's leaving, in this case 0E. So over here we look at the frame, and indeed it's leaving from 0E, and it's destined for 0B, which is this PC. We have a MAC address table, which is not fully populated, so it is still learning, as we talked about. So what you do is you look at this and you go through and you answer a couple of questions down here. So what's going to happen is this packet comes in to FA9. So they ask you some questions about where the packet will be sent. So the destination is 0B. If we look in the MAC address table, there is no 0B. So what it's going to do is it's going to send it out the ports that have connections. One little tricky thing about this is you'd be tempted to check all the ports, like 1, 2, 3, 4, etc. But what happens is it's only going to send it out ports that are connected. So it'll send it to 1, 3, 5, and 7. It will not send it out 9 because that's where the packet came from. Down here we need to look. The first one says the switch adds the source MAC address. That's not correct. It doesn't look. I'm sorry, it's source, so yes, it does look. So the source is 0E. 0E is not in our MAC address table, so it's going to add that. The frame is a unicast frame, and it's going to be flooded to all ports because we don't know exactly where that is. So then you can do the check, and it says, hey, you're correct. And then what the nice thing about this is we can click new problem, and it will change where the frame's coming in. It'll change the actual frame that's being sent, and it will change the contents of the MAC address table, and then you get to answer the question again. So I think that's a really cool activity that makes sure you fully understand all the things that are happening or going on in the switch. The next thing we talk about is switching domains. In the older Cisco curriculum prior to version 7, this was usually covered in Cisco 1, but this is one of the topics that they moved to Cisco 2 in the version 7 curriculum. So you may or may not have had discussion about this, but we're going to talk about collision domains and then broadcast domains. So basically, first thing is, where do we have to worry about collisions? Well, that's primarily when we have a hub network where things have to operate in half duplex, and two machines simultaneously or pretty close to simultaneously may decide that they can both talk on the network, and they have a collision because their packets collide. and both of those packets are do not show up intact. They're both damaged and have to be retransmitted. A collision domain is the collection of machines for which a collision might occur. So hubs extend collision domains. That means if we have hubs with other machines on it, our collision domain gets bigger, and the machines on both hubs may be able to be involved with collisions with each other's. Switch ports segment collision domains. So that means as soon as you hit a switch port, uh, that's the end of the collision domain. And also routers segment. So if you hit a router port, that's going to kind of terminate or encapsulate the collision domain. Here they're talking about a few things um, that I don't know are exactly related to collision domains other than maybe the duplex negotiation. Because if you end up negotiating down to half duplex because only one of the devices or one of the devices is only able to do half duplex, then you're both going to have to do half duplex. And then negotiating speed. So here, these have negotiated to full duplex and 100 megabit. But if there were more PCs here, off of switch 1, maybe there was a hub here, those would all be in a collision domain. Now, a broadcast domain is all the machines that are going to see a broadcast that a machine sends. So in the case of a layer 2 broadcast, all of our bits in our MAC address are going to be set to 1, and then that packet is sent out. And any machine that sees that, frame, we're talking layer 2, any device that sees that frame and sees that the destination MAC is all ones, we'll pull that frame up and process it just like it was a unicast frame destined for that particular device. Now, in the case of broadcast domains, hubs extend broadcast domains, switches extend broadcast domains, however, routers segment broadcast domains. So here, these would not be in the same broadcast domain, although they would be in the same collision domain. So we will play this animation. So we have a packet coming in. It goes out, since it's a broadcast, to all the other devices on the switch. In this case, one of the switch ports is connected to another switch. So since switches extend broadcast domains, it's going to send it out to all the devices connected to it as well. I will probably give you some figures and ask you to either mark or tell me how many collision domains there are and how many broadcast domains there are. So you do need to remember what extends and what segments that. Now then, networks can get congested. There are several things that you can do. At UK, back in the 80s, our campus network was just one huge network. Everybody saw everybody else's traffic and everybody else's broadcast. And as we got more and more machines, at that point in time, the CPU had to process the packets that were coming in. It got to the point that they just couldn't keep up with all the network traffic. So that was severe congestion. So there are several things that you can do. Basically, you can segment collision domains by putting in switches instead of hubs. That's why hubs are obsolete now. You can negotiate the highest speed possible so that clears up the congestion, and as we go to higher speeds, those all become full duplex. Kind of along that lines, do full duplex if at all possible. You can try to get high performance switches that are going to switch faster. Those switches can have large memory that is used for buffers so that you have plenty of buffers. And when you get switches, they say high density or port density. That basically means a large number of ports. So if you can connect everything to a switch, that's going to isolate your broadcast domains and make your network function better. 224 is to check your understanding on switching domains. So you can do that on your own to make sure you understand what we've been talking about. And as I said, Module 2 is really short, so the third section is the practice and quiz. You'll learn that the first section in the module practice is a what did we learn. Usually the list is much longer because the chapters are longer, but we learned about forwarding and switching domains, so you can read through that and make sure you understand everything. And then here's the module quiz for the entire Module 2, which you can do on your own as well to see how you are understanding everything. And that finishes up Module 2.